a current, this one come from magnetism. How I want to take know? See am here. Even if you don't understand from any other place, I mean I go know am from magnetism wey dem call inside. But if I say come from electromagnetic field, you go confuse. If I say vector field, you go confuse. So let me call am electromagnetic field from magnetism. A current of 5 ampere passes through a straight wire in a uniform magnetic field of flux density. Make we use B as our flux density. Then give us 2.0 times 10 to the power of minus 3 T. This T means Tesla. Tesla. That be the unit for magnetic flux density. Some textbook, 1 Tesla will figure you about. Is it Weber per meter square? Put am comment if you correct. If you know what they talk about too. If you get this unit of this flux density as Weber per meter squared. Confirm if now Weber per meter or Weber per meter squared now equivalent to 1 Tesla. Now information I just give you. I know find trouble. So now be this B. Wetin again wey dem give? Current I will be equal to 5 ampere wey dem give you. Calculate the force. They say we calculate force. Not only force per unit length. See am here. F over L. Now in the same way you calculate exerted on the wire that when it is inclined at an angle. That means angle, they don't give you angle 30 degrees to the field. Like this sometimes where the angle, if the angle na 0 degree, it means say if the angle na 0 degrees, it means say the force will be 0. But you don't get anything you want to do when you get sine 0, will be 0 multiplied by B, multiplied by I, everything will turn to 0. So that means if the angle na 0, if the angle dey perpendicular, when we say perpendicular, it means to the right angle will be 90 degrees. You go come check sine 90. What if it's sine 90? It will give you information. What if you get the angle to be in the opposite direction or in the same direction with the motion? You go know about the Fleming's left hand rule, right hand. You're supposed to get all this information because now you don't read the language this place. I don't want to bug you. Make you treat that one for another topic or another video where you will get time, learn and well. Let me know for comment section if you get interest so that I will teach you those things. But you need to know and may pass. I know will like give you. So now we don't give you all this information. How I want to find the final answer. See the formula. When you talk about F, the force carrying current conductor or man, don't just even mention those ones because myself, I don't even tire for this particular one. L sine theta. And the formula we use. So now, you see, say they say make you find force per length. Force per length divide both side by L. Divide both side by L. Now you get this one low. So as you cancel L and this one, now B I sine theta will remain. See what I thought in case if you confused. As you get F equal to B I L sine theta. If you divide both side by L, divide both side by L. L and L will cancel. This one, now be this one. Waiting will remain BI sine theta, now be this one. I hope it's clear. I don't want anybody confused. So now this guy will define. But remember, say force, the unit now Newton. Length, the unit now meters. So you get the unit when you don't get the final answer as Newton per meters. Or Newton per meter like this. Forget to write the options. So now, this force per unit length, B, now be the flux density, magnetic flux density. See the value, 2.0 times 10 to the power of negative 3 times the current, now be the 5 ampere, 5 times sine of the angle where they give you. The angle now 30 degrees, sine 30 degrees. So make we calculate this particular one. Find sine 30 degrees. When you do them together, 2.0 times 10 to the power of, if you get the answer, talk and for comment section, negative 3 times 5 times sine 30 degrees. I put everything directly. Which I get now, 5 times 10 to the power of negative 3. If I want them in decimal, 0.005 Newton per meter. Confirm if now waiting you get. If you're now in standard form, 5 times 10 to the power of negative 3 Newton per meter is still correct. After all, they don't give us any option here, or they give us no right output. I hope say you don't enjoy this particular video.